My name's Amey Banarse. I lead the solution changing team here at Yugabyte. And I'm fortunate to have this role where I get to work with a team of solutions architects who are actually database industry experts. And then we collaborate with some of the customers, some of you here in the room today, and we help you solve some of the mission critical business application challenges, mainly focused on multi-region, scale, or resilience aspects of it. And those are some of the stories we'll be talking about today in this presentation. So let's get started. You all know what YugabyteDB is. That's the reason most of you are here in the room. And if you don't, you'll get to know a lot about it in the next 20 minutes. So YugabyteDB is a distributed SQL database. So think of it as a database platform which will allow you to scale, be resilient, and actually take your business applications without having to have any toil on your developers or operators and scale infinitely as much as the public or private cloud provides you. So that's the beauty of it. And the way we did this was we built this database from scratch. Our founder and CEO is here in the audience. You can ask him how we did this. And the best part is we still got you the most developer-friendly APIs available to you from this database itself. So you get a Postgres API. You can lift and shift your existing Postgres apps onto Yugabyte without any issues. Or you get a key value store, a Cassandra API, for your high throughput, low latency style applications. And the best part is, it's available as a fully managed service on Amazon Cloud. So you can actually go to cloud.yugabyte.com, sign up, and get free trial for this service today. Or if you're an on-prem data center oriented solution, you can deploy Yugabyte through its open source bits or our enterprise products on your same platform and get the same exact experience from a DBaaS perspective. So that's the beauty of being a cloud native, platform agnostic database provider. So why did we do this? The reason we actually chose Postgres and built it on top of Postgres is actually threefold. Number one, Postgres is a proven entity. I mean, no one wants to contest that right now. It's actually proven for a couple of decades. And I'll have a slide later in the presentation which will actually talk about how good the community is. But the best part is, we take the heavy duty stuff that a usual developer would have to do with Postgres and manage it behind the scenes on a Yugabyte distributed SQL database. So think of it as a native built-in replication. Resharding of your data happens automatically and transparently behind the scenes. And with that, you want to make sure it's enterprise grade because you all will be running your mission critical applications on top of Yugabyte. So whether it's your observability, meeting your data residency and compliance requirements, that's built in for you. You don't have to worry about it at all. And the third thing is, we started this company back in 2016. So we are fortunate enough to be born in a cloud native era where containers were a norm. CI/CD pipelines and chaos testing would happen every now and then. So we actually built it in a way that you could actually lose a node or availability zone or even a cloud region without having any data loss with Yugabyte. And those are the stories we're going to be talking about today. So this is a fun take for the technical audience here, right? Our goal is to have Postgres without limits. That's why a simple mathematical equation here, and this is how we do it. The Postgres itself actually is proven, as I mentioned, for 30 odd years. And the best part about Postgres is the ecosystem around it. Like you have tons and tons of these developers, researchers, who are contributing from universities, government institutions, Fortune 500 companies towards Postgres, and we get to adapt all of that easily without any issues. So you can collaborate with these companies or providers, and the best part is, even the top-notch public and private cloud providers have adopted Postgres. So think of it as Amazon RDS or Aurora, both offer a Postgres API as well. So it's a proven entity. Now, let's take a look at what does it take for a company and a product like Yugabyte to actually build innovation on top of Postgres. And here we're just going to take a quick look. Let's say there is a two-dimension axis here. On this axis, we're going to say, how much Postgres compatibility do you actually get from a product? And the reason we are doing this is because there are 400 databases out there when you go on DB engines. So you folks need some kind of a guidance on a quadrant to figure out, how do I go about selecting a database for my use case, at least in the transactional world? So on this axis, we're going to see, hey, what exactly does a compatibility mean? And on this axis, we're going to see between low, medium, high, how cloud native is my solution really? Now, on the first side, there is an imaginary line here where if you actually reuse the Postgres code engine from the community, you get benefit of the entire ecosystem, and you don't have to rebuild anything around it. So things like PG Vector, which is a proven research from multiple research institutions right now, that PG Vector can easily go and beat most of the vector databases out there. You get it, you can adapt it for free and bring it back to the community easily if you go through this runtime Postgres compatibility. Similarly, on the other axis, you have, if you follow the cloud native aspects, that is no shared nothing architecture, you don't really share a disk or a shared storage pool, you get a true no single point of failure style database architecture, and you can scale up and down to meet your peak demands and actually have happy consumers and users end of the day, right? So if you go from low to high, low being you take a single node Postgres, download it from open source, put it in EC2 and you run, or high being a true cloud native database offering. Unfortunately, we as Yugabyte, given the fact that we've been proving this for the last 8 years, we kind of sit on the top right quadrant right there, because we truly go ahead and reuse Postgres from the community. We don't rewrite anything in a different language. We use this as is. So every time Postgres community goes and adds new innovation, we actually work with them to parallelize it, distribute it, provide best practices on how to make it more cloud native. And at the same time, since we are inspired by Google Spanner as an architecture database to make sure that there is nothing shared in the architecture, we get the benefits of cloud native solution as well. And you have other databases like Amazon Aurora, AlloyDB, which are doing the same in terms of reusing the code base. But the best part is, when you want to run a true active system in a multi-region situation, you are looking at Yugabyte. And those are the stories, again, we're going to go through real quick. Now, the best part about this talk, and again, given 20 minutes doesn't do justice on how passionately we can keep talking about distributed SQL, one theme we'd like to focus on today is resilience. Because all the databases can give you APIs and features and values, but it's very hard to build resilience out of the box from a database platform. Now, industry defines resilience as an ability of a system to readily respond or recover from change, disruptions, failures. They can be machine-oriented, human-oriented, or even a natural disaster. Doesn't matter. You want to make sure that your systems are built in a way that they can actually truly adapt to these changes in the industry and in the market. And the way that's happening, because for the last decade or so, we have been building microservices and stateless applications like no one's business. Now the point is, all of this is running on commodity hardware. We don't have special purpose HPC hardware building right now for these applications. So you want to make sure that you put in the predictability of failure in your architecture right from the get-go. You want to make sure that you're designing for scale. And this comes with a viral adoption of some of these applications today, that day 1, you might have 10,000 users. Day 30, you might have 10 million users. So you want to make sure that you're not doing app-level sharding all the time or doing a replication technology when you should more focus on business. That's why you need scale and resilience built into this. So resilience itself is no longer enough. So that's why we define something called as ultra resilience. And this is where we expect, as consumers, that my applications are running all the time. I don't want anything to go wrong, even if there is a natural disaster occurring. And the best part is, when there's a live boxing match happening by Mike Tyson 2 weeks ago, I want it to work without any buffering or logging out of systems, which never really happened. But the truth being, that was my expectation as a consumer, that the system should just work without any issues. So let's look at what does a modern application really need to do this, right? The modern application kind of defines the ultra resilience in 6 different aspects. You want to make sure that there is an in-region resilience just to do native things, like usual things, taking out a disk, doing an OS upgrade, doing a patching, gray failure, those kind of scenarios. You want to make sure that you have multi-region disaster recovery solution. And this is important because routinely, you're going to have audits. You're going to have cloud failures happening. You don't want your users to be impacted because of that. The third and fourth thing is pretty simple. In this day and world, everything you do on cloud has to be ultra secure. No questions asked, okay? So you want to make sure that you're using custom SSH keys, you want to make sure you're using CA certificates. All that built-in protection is absolutely required. And the last thing is, you want to plan for the scale events. Even if your application users only have 1 million users, you should still plan to design it for scale so that one fine day, when you really go hit it out of the park in your business, you don't have to redesign or re-architect your database itself. So with these things in mind, let's take a quick journey on how does Yugabyte provide you these kind of scenarios fit into 2 different topologies. On the left-hand side, topology number 1, you think of it as 2 separate clusters of Yugabyte doing asynchronous replication of your data and making sure that your data is available in an active multi-region fashion so that if at all anything goes wrong, you have a second site activated without any issues. But if you truly want a single cluster of Yugabyte spanning multiple zones, multiple regions, or even multiple clouds or continents, you can actually opt for that. You can take a single cluster of Yugabyte spanning across multiple regions. Even if you lose one entire region, you're guaranteed no data loss in this scenario. And those are the stories we're going to look at real quick today. So starting with number 1, Paramount Plus. All of us here kind of know Paramount Plus, Paramount Studios actually, as one of those favorite movie studios that we grew up watching all the movies. Mission Impossible, Zodiac. I don't think the Zodiac Killer mystery is solved yet, but so what? We love these movies. Now, what does Paramount Plus actually do? Paramount Plus said, we're going to build a streaming engine by taking our movie content library and taking live sports and live events and streaming it to the end audience. A bold initiative. They had a perfect goal in mind to make sure that they bring Paramount Plus closer to their end users by going for a multi-cloud, hybrid cloud architecture, making sure it all works at scale, because during a live event, anything can happen. Just few years ago, you had someone slapping someone else during Oscars. You know what? You get a 10x scale in matter of minutes. You want to make sure that your database solution is designed for those kind of scenarios as well. And the other part was they wanted to enter new markets where data residency and compliance requirements were absolutely required. So think of it as European Union, GDPR compatible laws where they wanted to essentially enter. So what were their challenges before us, right? So with Yugabyte, they do a use case where once you sign up for Paramount Plus, your entire user experience is powered by Yugabyte. So whatever shows you watch, your favorite movies, during an NFL game, you bookmark your favorite players, you look at their stats, all of that data from user personalization perspective is stored in Yugabyte. But before Yugabyte, they were using a single node MySQL architecture. As you can imagine, single node, single point of failure. So the only way you could scale it is by adding more cores. And there's a point after which the EC2 nodes doesn't really go beyond 64 or 128 cores. And it's an extremely expensive solution to manage. So what did the team do? They actually went and built their own replication engine. And they were trying to make sure that all the app level shards are always up, even during a live event. And there was an unfortunate day, exactly 4 years ago, where that failed. So the replication link broke, which created a massive headaches for the end consumers because they didn't know if they're watching a live event or they got logged out or logged in or buffering happened, and that sets a very bad taste to the end user. So when me and my team, we started working with Paramount Plus, we said, let's do one thing. Let's make sure that your solution is multi-region, because you want to make sure that the entire solution is designed in a way that you can get the flexibility of cloud. And even if you lose a region during a live event, let's say because of DDoS attack or because of a link failure, it shouldn't affect your end user requirements or your experience itself. Second and third, we wanted to make sure that performance and scale was built in. You never know what happens during a halftime event at Super Bowl. A celebrity shows up and you get 3x the scale. So all those things were built in. So our final topology for Super Bowl was 3 region deployment in continental US with 5 availability zones inside it. And that guaranteed us an amazing insurance coverage, even if you lose any regions for that matter at this point. The highlight for us was the real world success story. So we have been proud to say that we have actually been a partner with Paramount to launch their Top Gun Maverick, their AFCs, Grammys, and even doing the Super Bowl exactly 9 months ago. So your entire Super Bowl experience, if you folks watched it, and hopefully your team won, that was all Yugabyte behind the scenes. So please make sure that next time when you're watching any of these live movies or sports on Paramount Plus, you do cheer for Yugabyte because that's what's powering your experience. Okay, let's switch gears to financial industry. And I see a lot of folks from financial industries here in the audience, right? So this is a case study that we worked with a large financial investment company, and they were building a net new app or redesigning some of their old applications and consolidating it into a net new app for aggregating external financial data and selling it or monetizing it to the end users, right? And the reason to do that was there was a new mandate given to them that they have to now change the data retention period. Rather than being a couple of days, you actually have to make it a couple of years. That means if you're an on-prem solution, you're either buying a lot of Dell or Supermicro servers or actually buying real estate to build data centers, which won't happen in the time that you wanted this to be. So we used that opportunity to first move their application onto Yugabyte and move their entire solution to AWS. And with that, some of the key requirements were you have to start with a lot more data than it was given, so about 150 terabytes or so, rather than being a couple of terabytes. And you need to have a very predictable performance for scale of read and write, even during that massive peak period. And which is important for a financial services company because you have to make sure that the end consumer experience is really good with that. So our solution looks something like this. We took Yugabyte cluster, put it in region 1, US East 1, second cluster in US East 2, active, and we partition it based on the global load balancer, and the users are essentially going through 2 different regions. And the entire solution, we put it in record time, in less than a month, the whole scenario. And this was a feat of achievement because it's a financial services industry application. We beat all the records to make sure that this was done without any issues. The third one is actually fresh in our minds because this comes from the Thanksgiving weekend. Just last weekend when all of the shoppers here were busy shopping, this is a real world story where how a global retailer deploys their product catalog on Yugabyte, and this is after going through Oracle and Cassandra and few other options for last decade, and finally resorting to a solution which is multi-region in the entire continental US, and making sure it's reactive and event-driven architecture. But the highlight was when a few years ago, the Texas power outage happened. When a simple snowstorm took out the entire state of Texas for 4 days and had without power, we ensured that this entire cluster was serving the US consumers traffic real time without any downtime or data loss. So our guaranteed RPO was 0, and the measured RTO, that is the time it took us for rebalancing these connections and the traffic from US Central to US West and East, was less than 10 seconds. And even for that, you don't need human intervention. Yugabyte ensures that this is completely automated through cluster and topology-aware drivers itself. So that's the beauty of a smart database in here. So real quick, some of the lessons we learned, let's say from these three case studies were, you always prepared for unexpected. You want to make sure that you have designed the solution for scale, and it's flexible enough that tomorrow if you want to choose a different cloud provider, you are platform agnostic for your entire solution in general. And at no point you should compromise on an end user experience and their performance. Like, it's a basic rule of business in general. So with that, here are the things that went wrong or go wrong in general. Like, you can actually lose the entire region. This happens at a norm. There are case studies out there. You can find the cloud regions actually go down. Failures can last a while. Texas power outage lasted for 4 days. That's not a norm, right? And you want to make sure that whenever such things happen, you have an ability to trade off between latency and the RPO as much as possible for the end users. It goes without saying that you should always do chaos testing. You want to make sure that you keep killing the regions or nodes without having any downtime to the end applications. So lastly, I'll leave you with, at Yugabyte, we take pride to actually solve some of these mission-critical applications for all of you. These are a handful of logos that I could fit in a single slide because of the real estate, but these are some mission-critical applications in some of the big names out here where you're truly using Yugabyte for a consumer-facing application. and very similar scenarios. You have multi-region replication and scale built in, and you want to make sure that you go fast and give a best seamless user experience possible to the end users. So with that, I'm up on time. Thank you all. If you have any questions, I'll be around in the audience. Anyone you see here with the purple shirt is from Yugabyte. You can ask them any questions all day long today. They'll be happy to walk you through, take your business problems, and walk you through how to create a solution for that. Thank you.